Hello everyone, welcome back. So today we are going to see the concept on section 3, services and networking. So this section, services and networking, is from the section number 3, and this is going to be like taking 20% in the exam for CKA. Okay, and under this we have several subtopics like network configuration, pod connectivity, and services and endpoints, ingress, core DNS, network policies. So how many of this, like 1 2 3 4 5 6, right? So today I want to cover some concept regarding the subsection 1, network configuration. Let's get started. Here you are seeing many things in this picture, right? I have just generated it using all the knowledge I got from several resources. I can directly solve the questions related to network configuration, but the thing is, it took me some time to gather all the details, information, knowledge to solve those questions. So I thought like it will be easy if I make a video like to refer back. So that's why I am making this, and also like it will be helpful for, I see like so many points from so many different videos. I can link all those videos I have referred in the description, but yeah, these are all the information I gathered. Now I just want to make a single video of covering all the important points to solve this section. Okay, so if you see here, I will start with this topic, IP addressing schemes, pod CIDR pizza model, and service CIDR phone book model. Okay, so if you see, right, this is managed by Kube controller, and this is managed by Kube API server. And I'm seeing some pizza here, that's why I came here. Jokes apart. So like, yeah, so basically if you see it clearly, it's like the IPs. Pizza is having one IP, and this pizza is divided into several IPs. Okay, come on, like what am I talking? And yeah, let's get started. So basically, what is the pizza here? A pizza here is like our cluster. So a cluster, whenever you are creating, you will be giving the right to provide the IP address range. Okay, so this IP range here is, for example, 10.244.0.0/16. So let this be the IP range. And in Kubernetes we follow CIDR, that is classless interdomain routing. And if I'm correct, there should be some calculation like 32 minus 16, which is 16, and 2 power 16 number of addresses are available through this IP range. So you can calculate, I think you will get some 65,554 something. So something like this. And what happens is, whenever you create a cluster, you should be dividing the pizza among the people, right? Same like that when you are when you have to create the nodes, like node 1 and node 2 and node 3. Think of this like a pizza slice. Okay, so each node we can create different resources here, like pods, services, daemon sets, and deployments, replica sets, whatnot, like several things, several resources we can create in each node, right? So if I am correct, the node should also have an IP address, right? A node will act like a server. So basically every server, node is just nothing but your system. So your system 1, like whatever your PC, whatever you are using, multiple such systems forms a cluster, right? So your system is like a node 1. So every system will have its own IP address, its own MAC address. So let's not focus on MAC address because it's not a personal computer. So every node will have a IP address. Okay, so for sure this IP address will not be random, and this IP address comes from cluster IP address, right? So how the IP address will be divided? Let's say I have this as the cluster IP address, and that will be divided like 10.244.0.0/24, 10.244.1.0/24. So here again it will have 2 power 8 and 2 power 8. Let's not focus on calculations. I'm just telling that when this part is increased, the number of addresses are decreased. Okay, thing is like this. Let's say node 2 is having this IP and node 1 is having this IP address. And it can have this many number of IP addresses. I think this should be like 255 number of addresses. So basically this system can have a range of IP addresses starting from 244.0.1 to 10.244.0.244. Why not 254? Because there are 255 addresses. 255th address will go as broadcast address, and the first address will be representing the that particular network. So that's why we will have 254 number of usable IP addresses. And among these usable IP addresses here, just remember, like this is the example I'm just taking. It can be the calculation will be similar, but it can be different ranges as well. So I'm just taking example like /24. So usable IP addresses. Now among these usable IP addresses, these are used for allocating IP addresses for pods. So the pods will get a real IP addresses from that are in the node. Okay, and because also one more thing you have to remember is whenever a node is created, the resource, which one is responsible? Kube controller manager. So that kube controller, you would have known already about this, right? Like what are all the components we have in Kubernetes. So this is responsible for allocating IP addresses for nodes. And since from this IP address only we are getting the IPs to pods, therefore indirectly kube controller manager is responsible for IP addresses of the pods. So this IP range which is assigned to the nodes is called as pod CIDR range. So CIDR, as I again mentioned, it's a classless interdomain routing. So that is one thing. This is about the pizza model. Okay, and let's come to phone book model. It's not that interesting as that of pizza model, but still we have to know, right? So let's come to that. And if I have to mention about services are responsible for moving the traffic, right? Like navigating the traffic to the pods or from the pods, etc. And let's say there are different kinds of services like load balancer, and we have like cluster IP and headless services like without cluster IP, kind of like different services we have. Okay, okay, now so this different kind of services will be having, and so every type of service serves some purpose. Okay, so node port, we will see that in detail in services explanation, but for now let's go into the topic. So every service will also have an IP address, because services are only responsible for navigating the traffic, right? So let's say a pod 1 has to communicate to pod 2 via the service only. So why basically we have different kinds of services? This load balancer is responsible for external communications, like from external resources. So there will be some IP to the service, and using that the external people can communicate to the internal Kubernetes cluster. So that service IP is responsible, right, to move the traffic. And for node port also, it is specifically for the nodes. It will be for the nodes, okay, inside the same cluster where different nodes, different pods can communicate. Similarly, this is a cluster IP, and it has this headless service is also having some different purpose like stateful sets and all. Okay, that we'll see later. Basically, this is for enabling communication between different resources. I mean, pods of different pods or containers of different places. So service also should have an IP address, and that IP address is actually not the real IP that pod, how the pod is getting. So this is like a virtual IP, and this virtual IP, if it is assigned for the service, that is fixed. That means, let's say I create a service in node 1, but node 2, node 3, all these nodes, even though they are having different pod CIDRs, that doesn't matter. Okay, so this virtual IP will be assigned to the service, right? Let's say here they took example 10.96. Let's also take the same thing, 10.96/12. So maybe this range is defined by Kube API server. So whenever you are creating a cluster, you will define two things. One is pod CIDR range, and second is service CIDR range. And here in the service CIDR range, it is defined actually using the Kube API server. This is responsible by the controller manager. So whenever you want to inspect and see the IP address range or the pod CIDR ranges of you can actually grep into the controller manager file, and you can view the pod CIDR range. Similarly, for service CIDR range, you can grep into Kube API server, and then you can view that service CIDR range. Out of that particular range, one of the IP addresses will be assigned to the services. Doesn't work node wise, okay, because let's say I have created this service in this particular node. Now what happens, the service virtual IP is actually communicated by kuproxy is a daemon set which will be running on all the nodes. So this kuproxy, whenever it is created in any one of the nodes, it will identify that okay, service number 1 is created in node 1. Let's write it in the IP table. So they will write in an IP table कि हाँ, if you want to communicate. So basically inside the services, right, we will have a label section, correct? If you see like in official documentation, labels, match labels will be there. So that means like what is this match labels are matching with the labels of the pods. So let's say one pod is having like app production kind of label. So we will mention that in the match label section of services. Now the services will be responsible for navigating traffic to that particular pod. It won't hold the IP address of pods. So let's say my external system is communicating with the service 1, this one, okay. So this using the IP address of service 1. But service one won't have to identify using IP address, because sometimes when pods are crashing, the IP addresses might change, right? That's why we are using services. Otherwise, we can use directly IP addresses. Okay, but generally communication happens through IP address, and IPs might change for pods. So why you are using services? Now, how do services identify the pods? Using the labels, right? So this way, this will write to an IP table. Let's say it will write into an IP table that so like service number 1 has this much of IP address. Now immediately whenever it so this will belong to node 1. Okay, so whenever my pod 2, which is in the node 2, has to communicate to this service 1 of node 1, the traffic will now route to the pods which has the matching labels. So let's say pod 1 is having some matching labels as defined in the service 1. So to that service 1, the traffic will be routed. That's how it works. So every proxy will have an idea of the service created in another nodes, and accordingly it will update its IP tables. So that is regarding the phone book. That is like a global, that's why it is like a global phone book. That means every node, independent of the node, all the nodes will have that information that this service is running here, like that. And yes, every service according to a node, it will have a virtual IPs, and it will update the IP tables according to the IPs it is having whenever it has created. Okay, so we have covered the IP addressing schemes. I hope it is clear. We also have about service CIDR range. So since every pod is running by a kubelet, every pod will have a location called etc/resolve conf. Okay, so this etc/resolve conf will be having a DNS IP, cluster DNS IP. We'll come into that in a later section, but for now, basically what is it? DNS, it is a translation, right? So if you want to, internally how it happens is, it doesn't directly hit the IP address of service. Basically there will be a translation, like some resource name slash the namespace, if it is default, like default slash svc means service dot cluster dot, like that it will be there, and that is resoluted into some IP address. Okay, so this is like a DNS name for that service IP address, and that cluster DNS IP is stored as a 10th IP address of the service CIDR. So let's say it's like for a service A, this is the thing. So we have created like this, but whomever the 10th IP address is there, we will see this all in practical, then you will be clear. But whomever is the 10th IP address, that will be our DNS IP range. Now that will be stored in the etc/resolve conf inside every pod. So whenever you create a pod, you can inspect it and go to this location, etc/resolve.conf. There you will be finding this 10th IP of the service CIDR range. I hope it is clear for you. Now this section is completed and you can take a break of some time and then you can revisit or you can restart. Okay, so now we will be seeing the next section here. So that is on the life cycle of a pod. Before I think this is what is important. Now actually it cleared a lot of the concept for me, like how it is happening inside. I need that clear view. So basically I captured all the relevant details for pod life cycle. Let me explain you. Let's say I'll just reduce this. Okay, so let's say you are creating a let's say you are creating a pod. What you will do, you will write like kubectl or k apply -f pod.yaml, right? Now immediately the pod gets up and it is running. How is it possible? And every pod will have an IP address. How is that possible? I told you, right, like every pod will get an IP address using the pod CIDR range of that node. And who is responsible for assigning that IP address? We are not doing anything, right? And also something communication should be there, right? Some communication channels should be there. Who is that responsible for these communication channels? And what are these? All these doubts I got. Okay, so let's see now what happens. Generally, if you ran this command, the request actually goes to Kube API server. And our Kube API server will get the request. Okay, so user has requested this. Let's do one thing. Let's save it in the etcd, the desired state. So it's like the pod has to be created. Then the user has just requested me, the pod has to be created and the pod has to be scheduled in one of the nodes. This is the desired state which is written to etcd. Now our Kube scheduler will not be silent, right? It will be listening always. Whatever it is happening, it will be very active. And this Kube scheduler will be listening and checks that our current state is not same as the desired state. As per the desired state, I have to schedule this pod to some of the node. So the scheduler will see and constantly watch like that and to the API server, and it will assign, let's say, node 1 to the pod. And also it should again not listen to same etcd and think that it is not scheduled, right? So it will update the etcd. Now oh my god, that's Alexa, I think. Let me stop. Okay, sorry. So yeah, so now what happens? There will be a kubelet, correct? on this particular node. Technology is scary a bit, actually. I'm not sure why the Alexa started listening like I really thought there is some person in the room. I mean, who is that? That's fine. I think it's still listening. I'm not sure. So it's scary, but still let's continue. Node 1. Now the node 1 is responsible for that pod. So every kubelet is like a captain in that ship. So let's say the ship is the node, and our captain is kubelet. Now this kubelet is responsible for CRI, like it is calling a CRI, container runtime machine, and this CRI is having like container D or Docker, whatever the implementation of CRI it is, and that is responsible for starting a POS container. Okay, wait. We are not asking to start the POS container, right? We want, let's say, this pod YAML is responsible for Nginx container, but why it is creating a POS container? What is it? So I will explain you like using a scenario. There is a friend of yours, and you are also there. Both, or let's not today, but maybe like 10 years back or something, there is no book my show. You have to go to movie theater, and then you have to basically stand in the line and buy the tickets. So you belong to that era, okay? And during that day, what happened is your friend is and you are standing in the queue, and there are lots of people in the queue for the tickets. It's like a very huge popular movie that everyone came to buy the tickets. And okay, I'm a very okay. So yeah, now what happened? Your friend want to go to take a call. Now your friend will tell like, okay, please hold this line for me, I'll come back, like that, okay? Or she will tell to this guy also like, I'm here only, so don't let the others to come. And she will tell to her friend also, and she'll take a phone call. But by the time she comes back, I mean, it's a very huge queue, okay? Her now by the time she comes back, these people are all random people here. She didn't see, okay? She couldn't so she didn't see. She again goes to same place, but everything is changed. Now again what she will do, she has to find the friend, right? So she will find her friend here, and oh my god, we already came here. So she will come back and join here, right? So that way she will find her line, and they can get the tickets successfully and then go to theater. Now here, why am I saying all this example? See, the concept is your pod is not just a pod. It will have container. Let's say there is some dependency containers like database container also. So there is container 1, container 2, and so on. and each pod will be assigned with an IP address. How it is assigned with an IP address? So here also there is one more concept called host network. Okay, I'll jump into this, sorry for cutting in, but host network. There is if you see clearly in documentations, host network attribute will be there, and that can be either true or false. Now what does this mean? A false means you are not taking the host network's IP, you want a separate IP. Okay, let's say host network is true, that means you are saying that I want a same, I can adjust with the IP address of the host IP. So what is our host? Let's say node 1 is having the IP address of like this. So our pod will be getting the same IP address as host. Then here comes the security issues, because it is in the same host, right? Anyone can access that pod. So you have anytime like no security issues kind of containers means, then only you can give it as true. Okay, some for some specific reasons you can give, but generally it will be like false. By default also it will be false. So what happens if it is like it need a separate IP? Basically it will be creating with a network namespace. So let's say your node is like this and you want to create a pod inside this. So by default host network will be false. That means it will get a separate network namespace. This is my node and this is my pod. Similarly, there will be if you create a second pod, there will be second network namespace. Now so this network namespace will be holding some one thing is IP address, and this will also have a separate IP address, so that every pod will have a separate IP address. But actually not only that, it holds some other network information like whom it should connect to and all. We will see that. Okay, so there will be some bridge or a switch, okay, based on whatever the technology it is. And let's say this is like let me take it as a big one, and this is like a pod 3 and this is like a pod 4. Okay, so this I will be having IP3, IP4 kind of. Now how the communication happens is basically the network namespace will be created, right? This network namespace is a basic Linux network namespace. Now why am I telling all this? So we are here, right? POS container. So this POS container is responsible for holding network namespace. Just like your friend is holding a line for you, the POS container will be holding network namespace. Why should it hold? Because the container's expectation is it will get restarted, it will get down, or it will get crashed or recreated. different things might happen to these containers. And when the IP address is dependent on this, let's say your friend is not there, you don't identify the people around, and you just went to take a call, you come back, and people say that you don't belong here, just go back, and again you will go back. It's not fair, let me go back, let's not see the movie, or the tickets will become later. So such kind of things. So that's why your friend is there, or someone, you should tell them that okay, please hold my line, and then you come back, right? That someone is the pause container here. So this container is like, it's always in the sleep mode. Okay, so, and it doesn't run any applications, nothing. It is always in the sleep mode. Since it is not doing any action, it's always in the sleep mode, it's there is no chance that it will crash. So that container is a pause container, and since it will never crash, that's why it will, I don't say it's never crash, maybe it will crash, I'm not sure, but most of the cases, why do it creates a pause container is generally, if the pod crash, pause container, of course it will also be lost, that we are not sure. But inside the pod, even the other containers are crashing, the pause container will always be like a monk on, okay, it will always be in the sleep mode, doesn't host anything, so there is no chance of it getting crashed. Okay, so in such conditions, this will hold the namespace of the pod. So that's why it is holding a namespace of the pod. So even the other containers are crashing, and it won't to come back or join again. It will think, okay, I belong to this particular namespace, and it will join here or restart here. And since the IP address is held by pause container, so it gets recreated, recrashed here. So since that is holded by the pause container, basically it gets into that, like it can be identified with that same IP address. So that's why here you have to note down, like inside the pod, even though the containers get crashed, the IP address will not change, because there is someone over there that, okay, please, you can still hold the same network name, because see, it will be in the same namespace only, right? Even it is recreated, who is holding that, like an anchor, who is holding that namespace? This pause container. Because if this pause container is not there, if it is crashed, the network whole namespace will be breaked. Okay, and it doesn't know where to join, so it will be recreated and joined somewhere else as a new network namespace, and it will be all a problem. So in order to not this getting crashed, when this container is restarted, so this will be holding the network namespace. So there is no link of holding this to the network namespace. So that's why even it is restarted, this is not broken, that's why it is again holding in the same names. But here you have to understand one thing, but if a pod only gets crashed, then IP addresses will be changed, because the entire pod is gone, then again it will be rescheduled to not only same node, it may go to another node also. So that chance is also there. You can also add like taints and tolerants if you don't want to go to that node. all those things you can do, but still like probabilities are there. I have seen so many times when pods are recreated or crashed, IP addresses definitely will change, but inside the containers are created or crashed, then IP address will not change. This is a very important thing which I identified. I think I'm going too much deep. Yeah, I think this is needed. This understanding is definitely needed. Now we are here in the anchor. Now we come to step 5, which is CNI plugin. Now that a pod has a network namespace, but it needs an IP address, right? Someone has to connect to it, definitely. Now the kubelet sees a location called etc slash cni slash net.d. This is specific to node, okay? This is not inside the pod, this is specific. And what is this location? It's a location for a CNI plugin, container network interface. So before I tell what does this CNI plugins do, there are different kinds of CNI plugins like Flannel, WaveNet, Calico, Cilium, and several other CNI plugins are there. These are all implementations of CNI standard. And what are the responsibilities of this? Basically, when you create a cluster for network communication, see, generally pods are recreated, thousands of pods are creating, thousands of pods are deleting. Every time IP addresses has to be arranged to it correctly. Not only IP addresses, I'll tell you one thing what CNI plugin does. So it is creating like a Ethernet pairs. So let's say I will take red. Okay. So from here I want to connect to this bridge. Why should I connect to that bridge? Because if I connect here, the same bridge or the switch, if I connect to this pod, the communication will happen, right? So that kind of pairs it will create. This is called the Ethernet pairs. Now, so every pod will be having like at 0 at one end. Think like it's a water pipe, okay? So these are like houses. Each house is having connection to this main pipeline, and so if you want to send something, you can send this via this pipeline. So this will have like an IP table that, okay, so if at all you want to go from here, you can come like this, and then that will be translated. So that IP tables will be there, translations and all will be written, and this creation will be there, and every end here will be like v@1, v@2 from the pod 2, v@3, like that. But pods near the pod endings will be having like at 0 only. It will not be like at 1, at 2 and all. So but this will be like v@1, v@2, v@3 and so on. So here if anything, the request is not inside this bridge, there will be also a default gateway which will be written in the IP tables, like, okay, so if at all the request has to go out of this, then it will check the node's IP tables, and via this bridge the request will go to the next node or external world, okay? That's how the communication happens. But creating this virtual pair, I can refer you to the Udemy course for Mumshad Mohammad's course. You can refer there how nicely he will explain the creation of Ethernet pairs and all, manually how you can create using the commands. So if you see, you can understand, but I think for this, I think this much is fine. So basically at the end he will also tell that these all manual things can be eradicated by using the CNI plugins. Now see, every time you create a pod, all you have to create connections. You have to create connection from this to this, you have to create a connection from this to here, you have to also create like this bridge network and default gateway, all those different pairs, how the communication should happen from this pod to that pod, everything you have to write manually. This is a very tedious task, right? Like if you are using like thousands and thousands of containers or pods, it's a very tedious task. So but you're not doing it, right? When you create a pod, definitely automatically it is getting created and automatically it is getting spinned up, the Ethernet pairs, all those things are happening in the background, but you don't know. Within fraction of seconds the communication can happen. So who is responsible for all these tedious tasks? That is CNI plugin. So definitely the CNI plugin will be there inside each node. If you go to the node and check here, this will be the implementation of that CNI plugin. And if you want to see like different kinds of plugins that cluster is having, then you can go to /opt/cni/bin. Sorry, this, I think this only, yeah. Here this is a binary files will be there, which is having all like CNI related the implementation files will be there in this location. And in this location, whatever you are using, let's say flannel, and flannel related configuration file will be there here, and you can check into that. And now this CNI plugin is creating this with pairs. It's like a wormhole, okay, because one end of communication goes to another end, just like a wormhole, okay. So after creating this with pair only, the CNI will look at the pod CIDR range and grabs it and assigns to that pod at the 0. So this at the 0 will be having some IP address, same like the IP address of the pod. So basically pod's IP address will be arranged by the CNI plugin after creating this Ethernet pairs. Now kubelet will tell that captain of the ship will tell to CRI that now we can start the actual containers. Now they are ready, IPs and all are assigned, connections are all there. Now we can start the ship. Now we can start the container. Not ship, but like we can move a wheel kind of thing, okay. Now the container should find the other services also, right? Sometimes this pod needs to connect to other pods, means it might need some services, right? In such cases, the kubelet will inject the cluster, even though we don't know, but definitely whatever the services are there, or our services, even though it is created, not created, but definitely the cluster DNS IP has to be injected into the container. So in the future purposes, that pod has to communicate with other services. That injecting of the cluster DNS IP will be happen inside the pod, and that location will be in the etc/resolve we have seen this earlier, and this will be having the service CIDR range, and that will be the 10th IP address of service CIDR, okay. Let's say if that is our service CRDR range is like this. Our 10th IP address will be assigned to that cluster DNS. In that particular node of that pod will be having this file storing that cluster DNS IP. This is fixed 10th IP. Okay, and when app asks for the database, like let's say database default service cluster local etc., it will go for that core DNS phone book. So this is like a main core DNS IP which will be written into this file, and the request goes to that phone book, and that's how the translation happens. And yeah, so we have seen a lot of things, CNI plugin, how the app starts and all. See, basically using this DNS cluster IP, I will explain you clearly one day, but for now whatever is needed in this topic I hope I cleared. Yeah, so this also we have covered, right? Anchor, the wormhole, the pause container, Ethernet pairs, CNI bridge, flannel. The flannel is a CNI plugin. Okay, so yeah, pretty much we have covered this. I think I need a black. So we have covered this. We have covered pizza, phone book, and life cycle of a pod, and also yeah, so we have also directly or indirectly covered this topic as well. Pod to pod, it is a same node, so it can use that CNI bridge, right, using this. And if at all it has to go to another pod in another node, it will leave the node 1 and goes via the physical network, or it can go to the, if it is in the same cluster virtually, it can also, it will have the IP table. Okay, basically that node will have an IP table, and using that translation network gateway that it can pass through. And talking to the services, kubeproxy is responsible for that. In detail we will see how the communication happens using the services. Yeah, so security implications. So by default basically pods, any pods can talk to any pods, because by default there is a network there is a switch or a bridge which is getting created, and every pod inside a node can talk to every another pod. When let's say some person maliciously has injected a pod into that node, he can read the data, right? Like there are no such conditions that pod should not be communicated to another pod. It's like a flat network, and there is a risk of breaching the data. So in such cases you will write a network policies. So network policies is also like kind of different section, and here, right, we will have ingress rules. In this ingress rules basically we'll write like which can enter, like you can block certain IP addresses, you can allow some IP addresses, you can define like who can enter, who can exit, all those things. Exit means egress, incoming means ingress rules. So that network policies you can write to avoid the risk of data breaching, because it's a default state is flat network inside the node. And these are some of the hands-on terminal commands. So if you see, this is how it is saying is inside the manifest file, inside the manifest file you will have YAMLs for the API server or cluster or the controller manager, all these things. So the resources, the components, main components of Kubernetes, how they created, they are also like deployments, right? They are also created using the YAML files only, right? So that main YAML files will be present in this location of manifest. So here you can find the YAMLs, and I told you API server is responsible for service CIDR range. So if you can grep that, I told you, right, we can grep into that. So that way you can grep, and this is the command. And similarly, controller manager is responsible for assigning IP addresses for the node and indirectly to the pod. So for pod CIDR range, you can go into the manifest same folder and you can grab cluster CIDR range. So that will be from the controller manager YAML file. And I would recommend you to do this. Also, if you create any pod, inside that there will be like resolve conf, right? etc/resolve conf, this one. You can verify that should be the 10th IP address of cluster DNS. And this is also inside the node. If you can inspect it and see, this is for the CNI plugins configuration. So here you can see the CNI plugin configuration. In addition, if you want to see more binaries what are there in the cluster, you can go into slash where is that, or I'll write here here it is. So this is a binary location for the several plugins in your cluster. You can see that information there. And this is the main configuration file. Here you can verify and see which plugin is responsible for doing all these tasks to the pods, Ethernet cables, IP addresses, takedown, construction, and all those things. So I think I have covered pretty much of this topic. In coming sections we will solve the questions on this topic. So yeah, thank you so much. Have a good day. Bye bye.